Hey folks, we are going to start our discussion on linear equations. We are talking about linear equations. Before we deep dive into this, what is linear? What is meant by linear? Linear means that whatever variables you have, they have a power of 1. Now, before we get into this, you might ask, what is a variable? What is an equation? So, a variable is something whose value can change or whose value we have to find. So, usually it is denoted by x, y, z, etc. This is a convention, and a, b, c's, etc. are taken as constants. And a combination of this makes an equation. Now, what is it that is very, very important to qualify something as an equation? The fact that I will have something like LHS is equal to RHS. Something on the left side and something on the right side, and an equality sign in between. Equal, equation. So these two words are correlated in that sense. So generally you will have to make an equation, or an equation will be provided to you in which you will have something on the left side of the equality and you will have something on the right side of the equality. What it literally means is that whatever quantity you have on the left side and whatever quantity you have on the right side, they are equal to each other. The quantity in question could be anything. It could be just x, it could be just a, it could be a into x, it could be a into x plus b into y plus c. It could be anything. One set of such result of LHS is equal to RHS is called as one equation. Now, an equation will be linear when LHS or RHS, either one of them, or both of them, whomsoever has the variables, the degree of variable, the power of the variable is 1. So, AX plus BY is equal to CZ plus D. Is this a linear equation? Yes, it is, because first of all, it is an equation because you have equality sign in between, and the powers of all the three variables that you see, x, y, and z, it is 1. All right. Uh, Now, the issue with this topic is how a complexity can be introduced in this topic is when the number of variables and the number of equations are played upon. So you get one set of equation with one set of such equality result. So let us proceed and see what all combinations we can expect in CAT. So this brings us to types of linear equations. Now obviously on the left hand side you see that the number of variables I have plotted, and on in the columns I have plotted the number of equations that are given to you. All right. So obviously the variables can be more 4, 5, 6, 7, but then it becomes increasingly complex to the point that you cannot really solve it in CAT or in general life. A 6 variable equation is going to be very difficult to deal with. So generally CAT will stick itself with 1, 2, or 3 variables. Now, if you have one variable and if you have one equation, this is a very standard, very basic sort of thing, something you probably deal with, mentally. For example, 2x plus 5 is equal to 10. You don't really need to write the equation for this. You can simply say that x is equal to 5 by 2. All right. The complexity which I previously mentioned, it comes in the two variable and three variable scenario. If you have two variables and only one equation, or you have two variables and you have two equations given to you. Similarly, you have three variables given to you and you can have any combination, one equation, two equation, or three equation. Now, three variables and only one equation is going to be a bit too much for an exam like CAT because it will take too much time. Think of it like this: variable is something that you have to solve for. This is the ask. The equations are something that will help you to solve this. The equation is the answer to whatever is being asked. So if the answer, if the help is lower than what is being asked, it becomes much more difficult to answer. So in CAT, to summarize, you should expect two variables, one equation, two equation, or three variables, two equations or three equations. Now we will talk more on these. We'll talk more on these four combinations. But before that, let us go and discuss how to actually solve a linear equation. So there are two primary methods. There are other methods also, but they are too complex or unnecessary for an exam like CAT. So you have two primary methods with you. You have substitution and you have elimination. So for a two variable or three variable scenario, you can have substitution, and for a two variable and three variable scenario, you can have elimination also. When I am saying substitution or elimination, I am talking about you having at least two equations. Because otherwise, if you only have one equation, there is not much we can do. So, what happens in substitution is you solve one of the equations for one of the variables. You express a variable of your choice in terms of the other variables, and then you put that value of your variable of choice in the second equation that is given to you. So for example, if I were to deal with this given system, I will go that x is equal to 9 minus 2y divided by 3, which is 3 minus 2y by 3. This is the value of x that I am getting from the first equation. I converted this to find the value of x in terms of y. Now I will substitute this value of x in the second equation. So I will get 4 times x, which is 3 minus 2y by 3 plus 8y is equal to 70. You can then go on and solve this and you will find the value of y. Once you solve for this value of y, this is one equation, one variable. I started with two equation, two variables. So I reduced the complexity to one equation and one variable, which is what substitution exactly does. So once I have the value of y here, I can put it back in this expression of x is equal to 3 minus 2y by 3 and find the value of x. The other method is something called as elimination. Now, this requires you to have some sort of foresight. You will multiply the given equations, you will rearrange the given equations in such a way that when you add or subtract the equations, the modified equations, only one variable remains or one of the variables is eliminated. So if I do this in the same example that we took for substitution, what is the observation here? If I multiply the first equation with 4, I will get 12x plus 8y is equal to 36. I have second equation as it is. I'll write 4x plus 8y is equal to 17. Now, if I subtract these two equations, I will get 8x is equal to 36 minus 17, which is 19, or x is equal to 19 by 8, which I can then put back and find the value of y. So far, is everyone clear? These are the two methods you will have to solve a linear equation. You can either substitute or you can eliminate. What is now let's talk about practicality of these two methods. Substitution overall is a no-brainer sort of thing. You manipulate the first equation, you find one of the variables in term of the other variables, you put it in the next equation, and you keep doing this, so on and so forth. So the advantage is honestly that it is very straightforward. However, if you have a two variable versus three variable scenario, in which situation will you prefer substitution? Would substitution be a very good idea for a three variable situation where you have three variables and you have three equations? So you will take the first variable from the first equation, you will put it in the second equation, which will give you the second equation in terms of the remaining two variables. Now you have the second equation, modified one, and the third as it is equation that you had. So you converted a three variable, three equation system into two variable and two equation system, and then you will probably continue doing this until you get your answer. So the limitation is that in a three variable situation, substitutions will increase rapidly. The number of substitutions that you will have to make, it increases, and that introduces avenues for errors, calculation errors, etc. Because look at this. Do you like this method or do you like this method? The left one has fraction as part of the solving step itself, right? I had x is equal to 3 minus 2y by 3, and then I had to put it here. Now I have to deal with this fractional thing. Again, it's not a difficult thing to do. Dealing with fractions is not something which is difficult to do. However, if I can avoid it, I should try and avoid this, because any calculation mistake that happens in simple equations like this, it would probably happen when dealing with fractions. So it can introduce fractions while solving. So if we were to pass a judgment for substitution for cat, we would say it is okay to apply in a two variable situation, because again you only have two variables, two equations. Might as well not spend too much time in being creative and just do it. uh, you know don't put too much effort in being creative. In a three variable situation, it's going to get ugly. Let's talk about elimination. Elimination is overall a much more efficient method if your coefficients are neatly aligned. If you can see the pattern, if you can see what I need to multiply with, it becomes a good idea, regardless of if it's a two variable system or a three variable system. However, if the coefficients that are given to you are in fractions, or if the coefficients that are given to you are large numbers, then it becomes difficult to identify what should I multiply with. In the previous example, it was very easy, because what did we have? 2y and 8y. It was clear I should multiply the first one with 4. If I wanted to manipulate on x, I would have multiplied the second equation with 3 and the first equation with 4 to get the LCM of 3 and 4, which will give me 12x and 12x here. So when I subtract, I'll get directly y as a value. So for smaller numbers, it is a good method. For a three variable situation, I would still say it is the better method. So if we want to bottom line this for ourselves, we would say elimination is something we should definitely go for in a three variable situation. For a two variable situation, we can take a call. You can rely on this, or you can if you are feeling creative, if you have developed that eye, you can go for elimination as well. All of this to say, this actual step of solving is not even the real issue that is going to come up in cat. The real issue is going to be in setting up the equation, because cat is going to ask you word problems on this. You would rarely find a linear equation given to you in a standalone format. You will have to make your equation. So with that, let us proceed on this one variable one equation type of question. This is your cat 2022 slot 2 question. Manu earns 4,000 rupees per month and he wants to save an average of 550 per month in a year. Which means overall, how much does he want to save? 550 per month into 12 months, that is 6,600 uh, rupees. This is how much he wants to save. Now, out of this, in the first 9 months, his monthly expense was 3,000. Sorry, yeah, his monthly expense was 3,500 rupees. Now his earning was 4,000 and his expense is 3,500, which means how much has he saved per month? 4,000 minus 3,500, which is 500. So he has already saved 9 into 4 500 rupees. From the 10th month onwards, he sees that his monthly expense will increase to 3700. For the remaining 3 months, his expenses will increase to 3700 rupees. So the question is, what should be his modified earnings for the last 3 months on an average, so that he meets this target of 6600? So let us say that his savings in the last 3 months on an average is X. This sum should be equal to 6600. Notice how most of my time in this particular question went into forming this equation. This will give you x as 6600 minus 4500, which is 2100 divided by 3, which is equal to 700. Once you get to this, it is easy. Now x is what? My savings when my expenses were 3700, which means my earning should be 700 plus 3700. My savings plus my expenses should be equal to my earnings. So your answer will be 4400. This is going to be the issue. You have to develop this sort of eye that I can write it in a strategic format so that I don't get confused with the volume of words and data points that is being thrown at me. So while this is a one variable, one equation question, which is probably the easiest in our graph that we made, right? This is the, I even said that I don't want to discuss this. Even then, there was some element of complexity here. So let us proceed. Let us go on to more complex, more frequently asked situations. Situation number one: two variables, two equations. Now, for the next four slides, I want you to look at the system from this lens. What is it that you can actually find? Forget what they are going to ask you. First, ask yourself, what even can I find? Then you ask yourself, what might be expected? And then to marry these two, are there any additional constraints required? All right. So let us start with this. You have two variables and two equations. Let's say it will look something like ax plus, let me use some other color. Let's say it will look like ax plus by plus c is equal to 0 and dx plus ey plus f is equal to 0. What is it that you are going to be able to solve for? Do you see that the number of equations and the number of variables is equal? Which means that I should be able to find the exact solution. I'm not going to be, I'm not concerned with the range of solutions or the, ratio of the values. I don't care about that. Two equations, two variables, I can find the exact solution. So this is a this is a situation which is very much in your power. If they give you two equations to solve for two variables, they are trying to go easy on you. So what might they ask you? Exact value of both the variables they can ask. I mean, you have the exact values, so they can ask you directly for that. What are these exact values? The caveat comes, there is a situation where these two equations might not have any solution, which we will shortly discuss. So that is called as being independent slash consistent. So they might ask you that, is there going to be a unique solution for this system of equations? Are there going to be infinite solutions for this equation? Or is this a system where you can't really have a solution? So these are the only two things they can ask you for: either the exact value of the solution, or does there even exist a solution? So tell me, when you can from the get go find the exact solutions, do they have to give you any additional constraints? No, right? Because do you need to know that x and y are integers here? You don't really need to know. You can use your substitution or elimination. You have two equations, two variables. You can find the exact value of x and y. So additional constraints are not required for a two variable, two equation system. When your number of variables and the number of equations are the same, you don't need an additional constraint. They will not even give you one. And because they have very less freedom, they have very less freedom in asking you questions from this particular slide, they generally just refrain for this. They will generally ask you for this: check if the system of equations has a unique solution, infinite solution, or no solution at all. They can try to complicate this. You find your exact solution, but the situation is such that from a real world example, it is given to understand that x and y have to be integer, and you get x and y as fractions. Then you would have to take that call to reject your fractional answer that you have gotten. And can anyone give me an example of such real world constraint? Number of apples. Let's say x is number of apples in this equation, y is number of oranges. Can it be a fractional number? They have to be integers. So that common sense that, fruits, coins, people, you can't get half a man, half a woman. You don't have that, right? So this is all there is for two variables and two equation sort of system. Most questions here are going to be for this particular thing, checking if there are going to be, unique, infinite, or none solutions. So we will discuss that separately. Let us quickly move to an iteration of this two variables family, where the exam maker has the power. Two variables and one equations. So what is it that you can find? If I just give you this, that ax plus by plus c is equal to 0, what is it that I can even find? There will be infinite solutions to this. If you look at this, this is what? This is a straight line. There are going to be infinite solutions to this. They might ask you for ratio or relationship between x and y. That is something they might ask. They might give you something and ask you for the range. So they now have a lot of freedom to ask you things, and this is what they prefer. So what can they ask you? What can they ask you? They can ask you for the integer solutions to this. They can ask you what is the maximum minimum of a variable given that both x and y are integers. They can also ask you what will the solution set look like. So generally in things like this, your solution sets would be in AP if the constraint is that you have to have integer solutions. All right. So given now let's look at it from the exam maker's perspective. They gave you two equations. Sorry, they gave you two variables and one equation. Now, if they are going to ask you anything on this, they have to give you something additional. Otherwise, you will have infinite solutions. Something they don't want to give you in writing. They avoid writing infinite unless it is sum of a sequence. So, what is it that they can introduce as a constraint? They can introduce the constraint that x and y are integers. This is the number one most common sort of situation that you are going to face. That the equation that you are making has x and y as integers. They can put an additional constraint, positive integers, non-negative integers, zero is allowed. They can put some, uh, condition that x can't be greater than this and y can't be greater than this, and they are also in addition integers. So what are the possible values? They can give you an inequality that x is greater than y. Now tell me what are the possible situations. So again, I hope you can appreciate they now have a lot of power, which means we have to be very cognizant in how we approach the questions such as these. Ria is solving a puzzle that involves finding pairs of integers. She knows that one number, say x, must always be greater than or equal to another number y. Is this an equation or is this a constraint they have given you? This is a constraint that x is greater than equal to y. Finding pairs of integers. Is this a constraint that they have given you? X and y are integers. What is the next data point? Y should not be less than minus 20. So y has to be greater than equal to minus 20. This is constraint number 1. This is constraint number 2. 3x plus 5y is equal to 96. Now I am getting y is 96 minus 3x divided by 5. Now what is going to be the general form of x? What remainder should x leave so that y becomes an integer? We will apply a remainder theorem. 96 by 5 will give you a remainder of 1. Then you have a minus sign, so you put the minus here. Then 3 by 5 will give you a remainder of 3, and then x by 5 can give you what all remainders? 0, 1, 2, 3, or 4. You want this equation to give you a remainder of the format minus 5, let's say p, a multiple of 5. If the remainder is a multiple of 5, then y will turn out to be an integer. When you check this, for x is equal to 0, when the remainder is 0, you will get 1 as the remainder. When x is equal to 1, you will get 1 minus 3, which is minus 2, which is not a multiple of 5. So that is disallowed. Similarly, you will check for all, you will land at 2 as your, allowed remainder. Which means that x is going to be of which format? 5k plus 2. A number that leaves a remainder of 2 when divided by 5. Now, once you have this, you start finding your values. You take an arbitrary value for, you take an arbitrary value. You take k is equal to, let's say you took k equal to 1, which will give you x as 7. Corresponding to 7, what is the value of y that I'm getting? So the x to y conversion is here, right? 96 minus 3x divided by 5. So that will be 96 minus 21 divided by 5, or 21. So this is your x, this is your y. So y is coming out to be 15. Now, because x is a multiple of k plus 2, which means x will increase with what? X will increase with a common difference of 5. So next value of x will be 12. Y will decrease or increase? If x is increasing, will y increase or decrease? You can check it here, right? If 3x increases, then 5y will have to decrease. And what will be the ratio? What will be the difference with which it will decrease? It will decrease with minus 3, the term that we had put here. So 15 will become 12. This is allowed for me. Now, till what extent of y can I go? 15, 12 to minus 20. This is the extent that I can go to. But can I take minus 20 as a value? All my values of y are what? Multiples of 3. 15, 12, 9, 6, 3, 0, minus 3, minus 6, minus 9, minus 12, minus 15, minus 18. That will be my last value. So from 12 to minus 18 is my values of y that are allowed. So this is going to be 11 such values. So your answer becomes 11. You can take k as 0. You can take k as 0. Doesn't matter. If you take k as 0, you will get x is equal to 2, corresponding to which you will get y as 96 minus 6, that is 90 by 5, which would have been 18. So x is equal to 2 and y is equal to 18. So you would have gotten that, but it would not have been part of your answer. Uh, See, you can't take y as minus 20, because the value of y for which you are getting an integer x is what? It is following the pattern of 15 minus 3k, right? And you can't fit 20. You can't fit minus 20 in that pattern. All right. Then let's move forward. Let's go towards three variables and three equations. What can you find? You can find unique solutions. Obviously, given the constraint that a solution exists, right? What can be expected from you? An exact value of all variables. And this is sometimes asked because finding the exact value of three variables, even when three equations is given, it is a lengthy process. So they can ask you that. It's not a difficult question, but it is going to be calculative. They can also ask you validity of a separate equation, which is consistent with the given equation, given system. They will give you equation 1, equation 2, equation 3, and they will say, is equation 4 true? The approach there is very clear. You express equation 4 in terms of equation 1, 2, and 3. If you can, then yes. If you can't, then no. Are there any additional constraints required? Not required. You have three equations, three variables. I don't need any additional constraints for this. Yeah. So let us look at some sort of questions. So this is the sort of question that I am talking about. They have given you three equations in three variables. They are asking which of the following equation is inconsistent with the above equations. What does that mean for us? What are they actually asking me? What they are technically asking you to do is, boss, solve this, find the value of x, find the value of y, find the value of z, then put it in this equation, put it in this equation, put it in this equation, put it in this equation. Whichever equation does not get equality as an answer, that is going to be inconsistent with the given system. Now, does this look even worth it to you? First, I solve these three equations to find x, y, and z. Then I put it in each of the equations. So that is solving three equations, then calculating potentially four different values. It is not worth it. So what is worth it is, can I convert each of the options that are given to me, you know, as a sum multiplication division of the given equations. For example, you observe that 2 4 3 3 2 4 4 3 2. Between the three equations, both x, y, and z have all three of x, y, and z have the same constants. So if I add these three, what will I get? 9x plus 9y plus 9z is equal to what? 33 plus 29 plus 28. That is 90. Or x plus y plus z is equal to 10. Your option number A has emerged, which means this is not your answer because this is consistent with the given situation. 6x plus 5y plus 7z. Can someone tell me how you will make this?
Subtracting third equation.
If you add the
Join.
first two equations, you will get this. 2x plus 4x is 6x. 3y plus 2y is 5y. 4z plus 3z is 7z. Is 33 plus 29 is equal to 62? Yes, it is, which means this is also consistent, not my answer. How about y plus z minus 2x is equal to 4? How do you get y plus z minus 2x? Equation 1 minus equation 2. 2x minus 4x will give you minus 2x. 3y minus 2y will give you y. 4z minus 3z will give you z. Is this equal to 4? Is 33 minus 29 equal to 4? Yes, it is, which means this is not your answer because this is consistent, which means this will be your final answer. Solving, finding the values of x, y, and z, it is going to be too lengthy. So, for questions like this is what we have to do. Is this elimination or substitution? We did elimination here. In this particular example, the values of x, y, z are coming out to be pretty neat, but that is not a guarantee. You might actually end up with fractional values of x, y, and z, in which case calculating each of the option is going to be a trouble. So you might think of this as your go-to approach. And obviously if you are at a situation in during the exam where you are like, I need to get the answer definitely, I don't need to be creative, I don't mind spending an extra minute, then only you should go for finding the exact values of x, y, and z. All right. All right, so let's move ahead to the pinnacle of this topic. Three variables and two equations. This is the toughest that they can ask you. What is it that you can find? You can only find relationships between the variables. What you are given is a combination of line and plane of solutions. Planes is out of your syllabus, so we are not even going to talk about the graph for that, but essentially all you can find is relationships because you are lacking one equation. Now if they do want you to find exact answers, uh, so before we get to the additional constraints, what is it that they can ask you? They can ask you for maximum minimum with restrictions. They can ask you to express one variable in terms of others, like we did for the previous example which took some time, right, where we expressed y in terms of x and then found the answer. Now any sort of answer that they expect from you in this particular situation, they will definitely have to give you some additional constraints, and those additional constraints usually are integers, integer solutions, which are bounded by real world conditions such as coins, number of people, number of fruits, number of anything which is which cannot be divided. So that is how they will give you the constraints. So this is intersection of planes. If the planes intersect, then it's going to give you a line. So the graph, the graphical interpretation of that is a bit complicated, which is why we don't touch on that. It's basically not possible for me to even draw it on a 2D surface. So it becomes a bit difficult to understand. Again, not relevant. All right, so let's move ahead with this question. 75 questions, 3 marks for correct, 1 mark for wrong, and 1 mark for unattempted. So one is deducted, one is added for you know not attempting a question, which means x plus y plus z is equal to 75, and the scoring is x 3x, because x are number of positive correct questions. Y is number of questions that I did wrong, so minus y, and I'm getting 1 marks for each of z. So z, this is equal to 97. Now they are saying that the number of unattempted questions was higher than the number of attempted questions. What are the number of unattempted questions? Y. What are the z. The number of unattempted questions is z. What are the number of attempted questions? X plus y. Which means if you add z on both sides, 2z is greater than equal to x plus y plus z, which means 75. or z is greater than 37.5. This is something which is given to you. So far clear, everyone? All right, great. Now I am going to use this in this particular situation. Now, first of all, I will want to get rid of one of the variables. Uh, can I subtract these two? I can subtract these two. Now, secondly, do I want to eliminate y? Or do I want to eliminate z? Or do I want to eliminate x? Which one should I try and eliminate? Or rather, which one should I try to save? Save for myself. Which one should I try to save? I should try to save z, right? Because I have an additional data point for z. So how can I save z? I will add these two equations. What will I get? 4x plus 2z is equal to 75 plus 97, which is 172. Now if I divide both sides by 2, I'll get 2x plus z is equal to 86. Now z is equal to what? 86 minus 2x. So far everyone's clear on this? All right. Now this is given to you as greater than 37.5. Now simply rearrange this. 86 minus 37.5 is greater than 2x, or you divide both sides by 2, you will get 43 minus this 37.5 by 2 is greater than x. So 43 minus 18.75, which is going to give you, let's say 43 minus 19. Let's do 43 minus 19, which is going to give you 24. So 24 is going to be your answer for this. Basically, you got this value as 24.25. So which is the next integer which is less than 24.25? 24. So your 24 is the answer. Do you understand the algorithm for these sort of questions? Write the two equations given to you, convert your inequality into something which is easily dealt with, and then convert the equality into inequality. Use the equality relationship into inequality, banking on the variable that you want to deal with. There was no use of y for me here. The inequality was in z and they were asking me about x. All right, let's do one more question. A donation box can only receive checks of 100, 250, and 500. On one good day, the donation box was found to contain exactly 100 checks. So, x plus y plus z is equal to 100, and 100x plus 250y plus 500z is equal to 15250. First, let's simplify the second equation. Divide by 50 on both sides. I'll get 2x plus 5y plus 10z is equal to, if I divide the other side with 50, what will I get? So that is 305. That is 305. All right. The maximum possible number of checks of 500 that the donation box may have contained. So I want to find the maximum value of z. Now, do you already know that x, y, and z are going to be integers? They are going to be positive integers, or rather non-negative integers. So that is the only constraint that is given to me. They belong to whole numbers. They can be 0 or positive integers. So let us convert this. Let us try and retain z. We don't want to get lost with z. So I will multiply the first equation with 2. So I'll get 200 here. I'll get 2x plus 2y plus 2z is equal to 200. If I subtract these two, what will I get? 3y plus 8z is equal to 105. What does that give me as value of y? Y is equal to 105 minus 8z divided by 3. Now y has to be an integer which is greater than 0. Correct? Y has to be an integer which is greater than or equal to 0. So is 105 divisible by 3? Is 8 divisible by 3? No. 105 is divisible by 3, which means 8z has to be divisible by 3, because this is simply what? If I rewrite this, this is what? 35 minus 8z by 3. So z has to be a multiple of 3, and it has to be a multiple of 3 in such a way that y does not cross the value of 0. So this has to be greater than equal to 0. So you can take a call here. Uh, let's take z as 9. 9 by 3 is what? 3. So 3 into 8 is 32. 35 minus 32, it is allowed. If I take z as the next multiple of 3, let me take it as 12. 12 by 3 is 4. 4 into 8 is 32. So 35 minus 32 is greater than equal to 0. So you can, at after this point, you can guess the value. Clear, everyone? Basically what we have done here is you have 35 is greater than equal to 8z by 3. So all that remains for me to do is I have already established that z is a multiple of 3. So I will take a value of z, which gives me my answer. Or if you want, you can, put it here. You can just calculate this value. You don't want to do hit and trial. So you write this as 3 into 35 by 8. You just calculate what this comes out to be. 105 by 8 is going to be 13 point something, right? Yeah. So what is the next multiple? A number which is smaller than 13, which is a multiple of 3. So the first such number is going to be 12. So your answer will be 12. All right. Next question. Aaron bought some pencils and sharpeners, spending the same amount of money as Aaron. Aditya bought twice as many pencils and 10 less sharpeners. So now, obviously, there are, demarcations. There are people here. I have Aaron, I have Aditya, and I will have some price for each of this. So, let me write sharpener and let me write pencil. So let's say Aaron purchased, or let's write pencil first, and then let's write sharpener. Let's write this neatly. Sorry, guys. Yeah, pencil and sharpener. Let's write it like this. So Aaron bought, let's say, X pencils and Y sharpeners. So how much did Aditya buy? Aditya bought twice as many pencils and 10 less sharpeners. This is what Aditya has bought. Cost of one sharpener is 2 more than the cost of pencil. So if the cost of pencil is, let's say, P, then what is the cost of sharpener? P plus 2. Now they have spent the same amount of money, which means x into p plus y into p plus 2 is equal to 2x into p plus y minus 10 into p plus 2. How many equations is this? This is one equation only. What are the constraints that you have? X and y are integers. So you have two constraints, that x and y are integers, and obviously positive integers. All right, so let us first solve this. No need to get disheartened. This is xp plus yp plus 2y is equal to 2xp plus yp plus 2y minus 10p minus 20. So yp cancels, 2y cancels, xp cancels, and somehow they have given me an equation where y is vanishing. Y is not even part of the picture, which makes it easy for me, right? So I will rearrange this. I'll get 20 is equal to p times x minus 10. Now, if x is an integer, x minus 10 will be an integer, and you want 20 by 10, you want price to also be an integer. So what is the lowest value of x that you can take such that this turns out to be a positive number, which is a factor of 20? You can take x as 11. 11 minus 10 will give you 1, which is an integer which divides 20. So if the smallest value of x is 11, what is it that they have asked me? The value of x plus 2x. So the answer will be 3 times x, which is 33.